Hello friends, this is JBrains again, and we're talking about adding fractions. This is fundamentals in test-driven development and evolutionary design. When we left off last time, we had just implemented the first example where we added fractions that didn't have a denominator of 1, fractions that were not integers. And it took us an awful long time to do that, and there was a lot of discussion, a lot of explanation, and we're going to move a little faster now. It pretty much works that way for me, that when I move to a new, or sometimes even just the first significant example in a feature, it takes me a long time to get going, and then everything speeds up. So I hope we're going to see some speed up right here, right now. So if we flip back over to our test list, you'll notice that we've crossed off the 1/5 plus 2/5 equals 3/5 test. And up here in the upper right hand corner, I'd written equals, and I think now's the time for us to implement equals. And of course, we're not going to implement equals in a bunch of tests about add fractions. Now, sidebar for just a moment. There are tools out there that will check the contract for equals in exquisite detail. hashCode equals builder, equals tester. I've even been involved in building one of them. We're not going to worry about that today. We're going to do a kind of a relaxed version of the equals method, in part because I just want to get roughly sure that my equals method is correct. I've written this equals method 2,000 times. I get it wrong, I don't know, once or twice a year, and I just want to make sure that I get it right. So I'm going to write a few tests just to make sure that I got it right. So this really isn't, strictly speaking, test-driven development. But remember, we're not here about labels. We're here about practical techniques that work. I'm not going to use the IDE's facility for generating equals for one simple reason. I really don't like the code it generates. I find it much, much, much too complicated. And for something as simple as 2 fields, I'm not interested in using it. Now, there are tools out there like Equals Builder that will let you build an equals method in a nicer way, more dry, more don't repeat yourself. But for this simple example, we're going to keep things simple. If you and I were pairing and you insisted on using Equals Builder, we'd start using it now. I might argue that, hey, let's try doing it this straightforward way for now, and we can always refactor the Equals Builder later. So the first thing I'm going to need to do is I'm going to need to create a new class. So let's go back to our project here, and I'm going to create a new test class for fraction equals test. Now again, I'm not going to make these tests totally and completely airtight. If I wanted to go that far, then I would go grab the equals hashCode tester and let it run the contract for me. And if you don't know the contract of equals, now is a really good time to review it. If you're mathematically minded and you remember the RST properties of an equivalence relation, then you're already up to speed. So we're going to do things relatively simply. I'm going to start with one really simple test, and that's making sure that equals fractions are equals. So let's try that here. Test method. So expect, let's see, same numerator and denominator. So this test will be really simple. Assert equals, let's say 3/5 and 3/5. Now it's very important. A few things are really important here. One, we have to make sure that we use different instances of fraction, because by default, of course, the same instance of fraction is equal to itself, or the same instance of any object is equal to itself. That's the default implementation of equals, the so-called identity equals. We want equals based on value, so we need to make sure that these are 2 different instances. And this is all basic Java stuff, so I'm not as concerned about the TDD aspect of it as just making sure that I don't do anything without, offering some kind of explanation. So this test should fail. And it fails because they're different instances. And you'll notice that in the failure message, we see the default 2-string representation of fraction. So let's change that real quick. Let's go into fraction, and let's add 2-string. And we're going to return a really simple version of 2-string. I prefer using string.format. I know we could concatenate strings, but I just find this looks better. So now if we run the test, we should see a very familiar message. Expected fraction 3/5, but was fraction 3/5. So whenever this happens, where the expected and the actual string representations look the same, this almost certainly means we haven't implemented hashCode. Or sorry, we haven't implemented equals, which reminds me, and let's flip over to our test list. If we implement equals, then we'd better implement hashCode. Fortunately, the hashCode can be really simple. It can be as simple as combining the numerator and denominator, multiplying by some silly prime number. All right, so now that we have a better failure message, let's do our basic equals. Now, I am admittedly absolutely going to cheat here, and I make absolutely no bones about the fact that I'm cheating. So the first thing I'm going to do is I'm going to rename this to other. It's just a naming convention I use. And I've typed this so many times that I type it pretty much from heart. So I'm just going to type it, and then we will deal with it. No, that would be nice. And that's the standard implementation of equals where you're just checking fields. This passes the standard contract of equals with the minor exception of the case where somebody subclasses fraction. If we really care, if we really have to worry about that particular edge case, we can simply make the fraction class final. I'm not going to bother doing that here, but if you and I were pairing and you insisted, I would do it. So that makes the test pass. So let's go over here and let's check that in. Wrote a single sanity check. Oops. Sanity check for fraction equals. As I said, this is not exactly test-driven development. In fact, it's nothing like test-driven development. This is the kind of poor test-driven development that I generally don't want to encourage. But again, I've implemented equals so many times. And if we were doing this in an industrial strength situation, I would use much better tools. But I don't want you to watch me test drive equals. In fact, that would be a really good exercise for you. Stop this video, take a few minutes, go grab the contract of equals from the documentation for Java's object class and turn those into tests. Make a test list and do it from scratch. See what you think. All right, if you're back now, we can continue on with the equals. I do want to have some idea that this isn't totally wrong, so we'll try different numerators. So unfortunately, there is no assert not equals. Oh, maybe there is now an assert not equals. That's new. Haha. I used to have to tell people that there's no assert not equals, and I don't know why, but now there is. So let's make the numerators different. This test should already pass. And it does. Now we can try different denominators. So 3/4 and 3/7. And that should fail. Now let's try a couple of interesting cases that I haven't thought about yet. So the first thing I want to think about is whole numbers compared to the corresponding fractions. So this is the same. This is the case where 5/1 is the same as 5. Now, I think this will pass because the default value for denominator is 1. Excellent. And what's one more useful test? We should probably just make sure that integers aren't equal to each other by accident. I doubt they are, but whenever somebody says, oh, I don't think that's a problem, that's the best time to test it. 6 is not the same as 5. Now there's one part of equals that we haven't implemented yet. And I'm going to draft the test. We know that 3/4 and 6/8 mean the same thing, but our code doesn't support reducing yet. I'm going to back this test out. In fact, I'm just going to delete it. And I'm going to go back over to our test list and make sure that we have, when we put here reduce, I'm going to put reduce in equals. I'm probably not going to need that reminder because I'm going to need reducing to work in order for equals and add to work together at all. But if it pops into your head, write it down. It's easier to just scratch it out later. So this is good enough to start. Run the test again just to make sure they pass. Let's commit our changes. And we'll go from there. And it might mean that when we implement something for add, that will encourage us to come back and implement a little bit more of equals. I think that's all right. But what this really lets us do is now go back to our tests for add and change them all to use equals. Now, we're going to do this the safest possible way. And the way that I like to do this, whenever I'm changing assertions in a test, I add the new assertions, make sure the test still passes, then remove the old assertions. Sound familiar? Let's see what that looks like. I'm going to start from the bottom and work my way up. Does that still work? Yes. Remember, if you add an assertion and the test still passes, that means all the assertions in there all pass. So that means that I can now safely remove these two because those assertions were all the same. And that works. All right. Well, if we can do it once, we can do it again. So let's duplicate this line. The result should be -2, but we don't need this int value thing anymore. Let's see if that passes. It does, which means we can get rid of that. And that should still pass. And yes, there's absolutely no reason to run that test again except just to make sure. We've all had instances where we've moved lines in code that shouldn't make a difference and somehow it does, and that's how we're discovering that there's some weird global data somewhere that's being written to, or there's some weird race condition. It only takes 2 seconds to check. There's no reason not to. It costs us a lot more to leave that bug in there and discover it in production 4 weeks from now. Well, if we can do it again, if we can do it once, we can do it again. So again, new fraction 7. Excellent. Now, if I really wanted to, I could use a trick for the last 3. And you know what? No, you know what? The trick might actually work. You know what? Let's give it a shot. So the first thing I'm going to do is I'm going to extract this method to check add fractions as integers. And now I'm going to introduce the parameters. Let's see if that still works. It does. Well, then I should be able to use the same thing down here. 3 plus 0 equals 3. It would have been better for me to add that to the bottom of the test, but I just pasted in the wrong spot. So of course, if I do it once, I'll do it again. All right. The next thing I can do is actually change the assertion. Now that I've got all three of those tests looking the same, I can add the assertion in here. So this is really new fraction expected result, and get rid of int value, and that should pass. So I can get rid of this, and that'll pass. Well, now I can inline this. Actually, I can inline this, and look what I end up with. All the tests look like the new tests. The nice one-liners that are easy to read. Now, it's up to you whether you think that's better or that's better. And again, if you and I are pairing, we'll argue about it. I probably won't insist on my way. We'll probably just do it your way. I'm mostly happy with either one. I happen to find this a little bit easier to read even if there's more duplication. Now, duplication is, in the 4 elements of simple design, ahead of clarity. And so I generally move in the direction of removing the duplication. But this is probably good enough for me for now, and I can't really put my finger on why that is. But like I said, I'm happy with either one. I just happen to like it this way. All right, so now all our tests use equals. In fact, I can now inline this sum, I think, and even that's still relatively easy to read. Let's run the test to make sure they pass. So now this is a good time to check in. Replaced remaining scaffolding assertions with assert equals. And now it's my favorite part of refactoring. And that's deleting stuff. If we go back over to fraction now, a whole bunch of stuff has turned gray. There's no longer need for int value, get numerator, and get denominator. So let's delete them all. And I'm even going to do the thing that I normally don't like to do. I'm just going to delete them all at once, run all the tests, and make sure they pass. I usually prefer to delete the first one, run the tests, delete the second one, run the tests, and delete the rest. And probably my all-time favorite message, I don't know if I have it here, removed obsolete code. I use that one quite a bit. At least when I use that one, I know I'm on the right track. Now, before we stop, let's quickly throw some hash code in there. I'm going to do this without writing tests. Don't tell anyone. Just because the implementation is really straightforward. How about return numerator times 19 plus denominator? That sounds pretty good to me. Of course, it's important to remember that this is also a legal implementation of hashCode. And if you're never planning to use this as a key in a map, then feel free to return a constant. It's legal. It turns all hashing into linear search, which is bad for performance, but it's legal. And it's probably better than having the default hash code, which is inconsistent with the value implementation of equals. Remember I said before that the default implementation of equals is based on identity. It's actually based on hash code or location memory. They happen to be the same thing in Java. What it means is that two different instances of fraction, even if they both represent 3/5, won't be equal. Well, two different instances of 3/5 will have different hash codes by default, and we can't have that. If we implement equals the value way as a value object, meaning that for equal values equals is true, then for equal values, hash code has to return the same thing. And that's the only requirement of hash code. The only actual behavioral requirement of hash code is that objects for which equals is true have to return the same hash code. If you make everything return the same hash code, it'll work, but again, it turns hashes into linear searches. So if you're never going to use this as a key in a map, that's fine. Since we might want to use this as a key in a map, or maybe for a better reason, because it's really, really easy to do, I'll use this little implementation of hash code, and everything still passes. I didn't change any code that's under test. So again, not strictly speaking test-driven development, but I know that I want equals in hashCode to at least, I don't want to implement equals in a way that breaks the contract of object. That breaks the Liskov substitution principle. And if I have to choose between doing TDD and respecting the Liskov substitution principle, I'm going to choose the Liskov substitution principle every single time. And again, if we're working on this in a real project, in a real industrial situation, and you and I are pairing, we would probably just use equals hashCode tester and equals builder and hashCode builder. All right, well, what we've done so far here is implement equals, not quite test-driven development, but an example of perhaps as sloppy test-driven development as I'm ever willing to do. Let's make sure that everything is checked in. Implemented hashCode consistently with equals. And I think this is a good place to stop. We need to get back to add and add more stuff. We're going to do that in the next video. Thanks very much for your time and attention. I hope you enjoyed it.